AI system architecture. So hello guys and welcome back to Curio Mike Show where curiosity gets mine. Today we are going to um, talk about the beyond prompts, like because the future of AI is not just about writing better prompts, using a better chatbot or connecting one model to one tool. This is the surface layer. The real AI systems are much bigger. They are layered architectures. They include reasoning, orchestration, contract, reliability, infrastructure, observability, security, and operational control. So, today we are breaking down the 5 layer AI architecture blueprint. This is a production blueprint for building AI that can think, coordinate, act, stay reliable, and scale. And this matters because most people are still asking which model should I use. But serious builders are asking a better question: how do I design the system around the model? This is the shift from prompt engineering to system architecture. Let's break it down. So, the future is system design. This slide shows the core contrast. On the left, you have the old pattern. A user sends a prompt to an LLM and the LLM sends back a response. This is useful, but it is isolated. It is prompt based on interaction. It is experimental, and it can help you write, summarize, brainstorm, or answer questions. But it is not yet a full production system. On the right, you can see the architecture era. Now the model is not alone. In the part of coordinated system, there are layers. There is memory, there are tools, there are agents, there are contracts, there is observability. There is infrastructure, and there is the real future of AI, not just model access or system design. Because the companies that win with AI will not just be the companies using the biggest model, they will be the companies that know how to design intelligent system. Around those models, most people are still using AI for the surface level. Serious builders are designing the full architecture. So the complete 5 layer blueprint. Now let's zoom into the full stack. This is the 5 layer AI architecture. Layer 1, cognitive architecture. This is where reasoning, planning, memory, and decision making happen. Layer 2. Layer 2 is the agent OS or orchestration substrate. This is the runtime layer that coordinate agents, tools, workflows, and execution. Layer 3 is capabilities and contracts. This is this defines what each agent can do and what it is allowed to access and where the boundaries are. Layer 4 is Agentic Reliability Engineering or ARE. This is the trust layer, observability, metrics, evaluation, safety gates, rollback, and human approval. Layer 5 is the agent platform engineering. This is the production infrastructure deployment, scaling, logging, identity, access control, secret, monitoring, and cloud reliability. Together, this 5 layer move AI from improvising to control execution. This is the difference between a clever demo and a production grade AI system. A demo can impress people, and architecture can survive real users. This is the game. So let's talk about the layer 1, cognitive architecture layer. So this is the intelligence layer, and this is where many people misunderstand AI. This is they think like the intelligent is just generation. You ask a question, the model gives an answer, but in the real system, intelligence requires more than output. It requires control. The system needs to know what goal is writing towards. It needs to understand context, and it needs to retrieve the right memory. It needs to plan the next step. It needs to decide whether to use a tool, and it needs to evaluate whether the action is useful or uh, safe. So this is cognitive architecture, and this layer includes reasoning looping, planning strategies, short-term memory, long-term memory, and state management decision policies, and action selection. In simple terms, this is the brain of the AI system, not just what should I say, but what do I know and what do I need to find out. What should happen next? Which action should be selected? When should I stop and when should I ask for help? In this layer is in the If this layer is weak, the system may still sound fluent, but it will behave randomly and it may hallucinate. It may lose tracks of the goal and it may repeat itself. It may take the wrong action. That is why cognitive architecture matters in transform fluent generation into goal directed cognitive control. This is the difference between a language model and an agentic system. So in the layer 2, agent OS orchestration substrate, layer 2 is the agent OS, and this is the runtime layer. And if cognitive architecture is the brain, the agent OS is the coordinated system. If control how agent tool workflows and execution flows actually run. In in a real AI system, one agent may not do everything. You may have a research agent, you may have an analysis agent, and you have a validation agent, and you may have an execution agent or compliance agent, and the agent OS coordinates all of them. It handles task decomposition, agent routing, tool innovation and workflow state, message passing and execution control. Without orchestration, you just have disconnected capabilities. One tool here, one agent there, one prompt somewhere else. That does not scale with orchestration. Those pieces become a composable AI runtime. This system can break down a task routine like work to the right agent, call the right tool, preserve state, and move the workflow forward. This is what makes multi-agent system possible. And this is where the builder needs to think like less prompt writers and like more like system architect. Because one AI start doing real work, coordinating becomes like just as important as intelligence. So layer 3 is about the capabilities and agent contracts. So the capabilities and the agent contracts, this is the interface layer. Capabilities define what an agent can do. Contract defines the rule under which it can do it, and this is where the agent design becomes serious. An agent should be treated like a free form black box. It should be treated like a bounded system component. That means it needs explicit permission into schemas, output schemas, execution constraint, and access boundaries. Look at the example here. A pronouncement like agent may be allowed to draft phrases, requests, but not approve final phases, right? A customer support agent may be allowed to access CRM record, but not financial system. A compliance agent may be allowed to review output, but not modify transaction records. This is controlled agent design. This matters for security and it matters for maintainability. So it matters for um, interoperability and it matters for the predictable behavior. Because like once agent can take action, boundaries become non-negotiable. You do not want every agent to access every system. You do not want every workflows to have unlimited permissions. You do not want to like an agent improvising inside and your production environment. So this is how like demos become disaster. So we have the layer 3 that prevents yeah. So Yeah. So layer 3 prevents that, like it turns agents into like discipline and components with defined responsibilities. This is how like this moves from improvisation to control execution. Yeah. So we are on the layer 4, agentic reliability engineering. So agentic reliability engineering, in so many videos that I have told you before, that it is a trust layer. And honestly, this is where the production reliability begins. Because one AI can take action, and this question is no longer can the model respond. The real question is, can the system be trusted under real operating conditions? This is a much harder question. ARE about making AI system observable, measurable, safe, reversible, and auditable. This includes tracing, matrix, evaluation pipelines, approval gates, rollback mechanism, safety policies, and human in the loop controls. Let's make this practical. If an agent like proposes an action, the system should record why. If the action is risky, the system should trigger an approval gate. If the execution fails, the system should detect if the agent enters a loop. The system should stop it if the result is wrong. The system should be able to roll back and recover. This is what this is what separate experimental AI from the production grade agent system. A chatbot can make a mistake and move on. A production AI system cannot. It is touches the customer data, financial workflow, cybersecurity, operations, producement, healthcare, legal document, or business critical system. So, and the reliability is option. ARE is how you build like operational confidence. It is the engineering discipline that makes agentic system trustworthy. Let's move on to the layer 5, agent platform engineering. Agent platform engineering, this is the infrastructure layer. This is where the AI system becomes real software. You can have a brilliant reasoning layer. You can have strong orchestration. You can have the clean agent contracts, and you can have reliability policies. But without platform engineer, the system will not survive production. The layer includes deployment, scaling, logging, observability, identity and access management, secret management, service reliability, and operational monitoring. This is where AI meets cloud engineering, and the system needs to be deployable. It needs to scale, it needs to secure, and it need to handle features uh, and the failures, and if needs to protect credentials, and it needs to manage access. So this is what it turns like architecture into an actual product, because production AI is not just about the intelligence, and it is about the durability. And can the system stay online? Can it recover? It can handle the load, uh, protect the data, operate, understand, and what it is like happening. This is the platform engineering. This layer makes sure the entire AI architecture is secure, resilient, maintainable, and ready to real world operations. So let's talk about the next, which is like synthesis, like the anatomy like of an orchestrated AI action. Now let's bring all the 5 layer together with a practical example. Imagine retail system detects low inventory and needs to reorder stock. In the prompt era, like someone might ask an AI, should we record this item? And the model might generate a recommendation that is useful but limited. In the architecture era, the system worked directly. Layer 1, like the cognitive layer, plans the reorder strategy. It looks at demand, past sales, supplier availability, inventory level, and risk. Layer 2, Agent OS routes the task to the right agent, maybe an inventory agent, check stock, uh, procurement and like agent draft the order, a finance agent check the budget, and the compliance agent validates policy. Layer 3, capabilities and contracts, enforce boundaries, and the um, and it can be like the it can have the purchase request, but it cannot approve the final purchases. The finance agent can validate budget but not modify supply record. Layer 4, ARE monitors the whole process. It triggers a human approval gate for high value orders, and it logs the reasoning. It checks from abnormal behavior. It creates a rollback path if something goes wrong. Layer 5, platform engineering makes sure the database, integration, identity, security, monitoring, and infrastructure all work reliably. This is the anatomy of an orchestrated AI action. A single prompt can trigger a cascading multi-layered system execution. This is where AI becomes more than a response engine, and it becomes an operating layer for work. Yes, the paradigm shift. This slide shows the shift clearly in the prompt era. Behavior is improvised generation. In the architecture era, behavior is goal directed and planned. In the prompt era, execution is isolated and single threaded. So in the architecture era, execution is orchestrated and composable. In the prompt era, design is often a free form black box. In the architecture era, the design is bounded by the contracts and schemas, and in the prompt era, failure can look like silent hallucination. The systems give an answer, but you may not know where it went wrong. In the architecture era, failure becomes observable, reversible, and auditable. In the prompt era, scale often means local demos. In the architecture era, and scale means cloud resilient secure system. This is the paradigm shift where are moving, like we are moving from the model as isolated tool to AI as production architecture. This is why AI system architecture matters. It is not just about making AI smarter, it is about making AI usable, reliable, secure, and scalable in the real environment. The model is important, but the system around the model is what makes it valuable. So here we are closing. So here is the final takeaway. The companies that win in AI will not just have the best models, they will have the best architectures because the models are becoming more accessible and APIs are everywhere, open source models and are improving fast. Tools is moving quickly, but the architecture is where the real advantage begins. Can you design the cognitive layer? Can you orchestrate agents? And can you define the contracts? Can you define your engineer reliability, and can you build platform layer? This is the difference between AI as a demo and AI as an operating system for work. So if you are building in AI, do not stop at prompts. Think in layers, think in systems, think in production, because the future of AI is not just asking better questions. It is building better architecture. Stop building demos, start building the operating system for work. This is the Curio Mic Show, where curiosity gets a mic, and I will see you in the next one. Thank you. This is Abhishek Yadav signing off from Curio Mic Show. Stay curious. Until next time, keep observing, keep interacting, and keep discovering. If you enjoyed this video, make sure to hit the like button, subscribe to the channel, and don't forget to press the bell icon so you never miss an update. Thank you for watching.